Hi, Joe Chu here, and welcome to Search Index Configuration. In this video, we'll be going over this rather mysterious component of the search index, seeing what it looks like and what it is able to do. The search index configuration is where all of the functionality for Solr is defined. Where the schema defines what to index and how it is indexed, the config pretty much defines everything else. This includes some things that we've already been enabling, features such as live indexing or changing values for different properties, like the auto soft commit max time or the filter cache high and low watermarks. What's also important about the configuration is that this is where the request handlers and components are defined, which is where functionality for the standard search query and more specialized search queries such as facet search, more like this suggestions, and highlighting are set up. There are two ways that you can make changes to the Solr config. The one that we've been using previously is to use the alter command in CQL. It is also possible to manually edit the XML that represents the config and upload that to DSC. Editing might be hard to do if you don't have the XML, but that can easily be retrieved by either using the describe command in CQL shell or by using the DSC tool command line tool. You can see both details about the latter tool in a different video. Afterwards, the search index will need to be reloaded, of course, for the changes to take effect. Since the config does not affect the index itself, you would not need to have that rebuilt. What we see here is just a snippet of the automatically generated configuration XML that is displayed by either the CQL describe command or with DSC tool. It can look a bit intimidating considering that we can't even show the entire output on the screen at once, but hopefully you won't find it so bad after we go through the individual parts. In fact, the configuration output generated by DSC is actually very different from the default configuration file you would see in Apache Solr, which pretty much lists every single setting that can be changed and also contains comments for the settings that can be fairly verbose. With the config generated by DSC, only the most often used settings are included. Settings that do not show up in the configuration will just use the default setting values. Of course, if you change the config to add back missing settings, then DSC will naturally use the settings that you specify, provided that they are still used and compatible with DSC search. We'll be quickly taking a look at the elements that you'll see in the generated config. The first two are the Lucene match version and the DSC type mapping version, which helps specify what version of DSC the configuration XML should be used for. These two elements really should not be changed at all. The directory factory determines how and where indexes are stored, and really should only be modified if enabling or disabling encryption for the search index files saved to disk. The index config element is an important section in the config since it controls the behavior of the index writers and how they work. The two notable settings in this section is the RT setting, which enables and disables live indexing, and the merge settings. Although the merge settings can be used to tune how index merges work, it is recommended to avoid making changes to these. One other notable setting that used to be here is the RAM buffer size MB setting, which controlled the size of the RAM buffer. The setting has been deprecated in DSC 6, and the RAM buffer size is now controlled automatically. The JMX element essentially enables the Java management extensions for the search index and makes available the JMX mbeans that allow users to pull statistics about how DSC search is running. The update handler defines how index updates are done and includes settings such as the auto soft commit max time and auto soft commit max docs, both which can be adjusted to control how often soft commits will take place. If live indexing is enabled for the search index, only max time would be relevant and will instead determine how soon index updates become visible for reading. The query element section determines how DSC search processes and responds to queries. Among the settings you see here are the filter cache, which you can adjust to control when the filter cache will start to evict entries and how much of it to remove. There is also the setting Enable Lazy Loading, which will only load fields for searching when needed. Having this enabled can help to boost query performance if only a small subset of the index fields are commonly used. The Use Cold Searcher setting determines whether search requests will be able to run immediately when an index searcher reopens the index following a soft commit. If false, any search request will block until the search had a chance to warm up its cache. The setting Max Warming Searchers specify the number of searchers that may be warming up at any given time. There will be more searchers warming up as the frequency of soft commits increases. And if the number of searchers trying to warm up exceeds the max, DSC search will start to return errors. The request dispatcher determines how the Solr HTTP API responds to specific requests. Among the settings that are visible in the generated config are the request parser attribute, enable remote streaming, and multi-part upload limit in KB, which determines if HTTP streaming can be used to upload data to DSE and how large that data can be. The attribute never304 is part of the HTTP caching element, which determines if DSC search can use HTTP 304 not modified responses. This is useful to set to true when working on development on DSC search, and running queries may return this response instead of the expected query result. The request handlers are used to receive and process requests for DSC search. There can be multiple request handlers for a search index and can have different functions as determined by the class used by the request handler. The handler will also have a name, which determines how requests can be sent to a specific request handler. There are several request handlers that we've included in the automatically generated search index configuration, which includes handlers for search queries using HTTP and CQL. There's also a handler for deleting data via HTTP and others used in the Solr admin UI. The search handler is the request handler used to receive and process search queries coming from the HTTP API. Some behavior of the search handler can be modified by setting values for the default settings, which include depth type, rows, q.op, and default field. There is also an appends list which can contain filter queries that will always run alongside search queries sent to this search handler. Another request handler is the CQL search handler, which supports search queries that are sent using CQL. The CQL search handler has the same defaults and appends property as the search handler, with the exception of the rows property, which can be simulated using the CQL limit clause. The CQL search handler is also registered with the following components: the CQL query component, the facet component, and the debug component, which are needed to support the search functionality available in CQL. The update request handler accepts and processes updates to the index through the HTTP API. This historically would allow for any type of write request, which would be able to then make changes to the Cassandra table, just like a CQL insert, update, or delete. However, in DSC 6, only deletes are supported now, and inserting or updating data should be done exclusively through CQL. Components defines how the search handler processes search queries, with each component providing different functionality. The components listed here are registered by default with the search handler in the auto-generated config, and can be used without any further configuration changes. Of course, the relevant parameters used by each component would need to be provided in the search query in order to receive a response. The CQL search handler does not necessarily use all of the components here, as functionality depends on what is available and implemented on the CQL side. In addition to the default components, there are additional components that can be useful. This includes the spell check component, the query elevation component, and the suggest component. As mentioned before about some of the other components, these here are also usable with a search handler using the HTTP API.